All right, let's jump right into this explainer. We're going to look at how to transform Claude from just a generic everyday chatbot into a highly precise senior site reliability engineer. Look, if you're in IT support, you already know that resolving critical incidents is a literal race against the clock. So today, we're completely upgrading your prompting technique to drastically cut down those resolution times. So here's the game plan for today. First, why generic prompts fail. Then we'll hit our 4 core techniques: role assignment, chain of thought, structured output, and contextual injection. Finally, we'll tie it all together with a real-world scenario, a payment timeout incident. Let's get into it. Section 1, why generic prompts fail. We've really got to start with the foundational mistake that so many engineers make, which is treating AI like a simple search engine.
Honestly, the best way to think about AI is like it's a brilliant, highly motivated, but totally green college grad. If you give it a vague prompt, something like, fix this database error, well, you're going to get generic textbook advice back. But if you provide a context-rich brief, saying you've got a 30-minute SLA and the database is Postgres, you give the model the exact grounding it needs to give you surgical troubleshooting steps.
Moving on to Section 2, Technique 1, Role Assignment. This is our first advanced tool, and it leverages Claude's unique ability to handle specific stakeholder perspectives.
The thing to remember is that Claude takes instructions incredibly literally. So by explicitly stating you are a senior SRE, you completely anchor its capabilities. That one simple addition shifts its output from a helpful conversational assistant to an authoritative, seasoned engineer who actually understands system constraints and production environments. It's a real game changer.
All right, Section 3, Technique 2, Chain of Thought. Now, this is where we really tap into the model's true reasoning power. You know, Claude is fundamentally a reasoning engine. When engineers ask it for just a quick answer, they are literally suppressing the exact capability they're paying for. By explicitly requiring the AI to state its step-by-step reasoning process before it gives you the final conclusion, you force it to map out its logic. For instance, if you just demand the SQL query outright, you're risking a hallucination or a complex business logic error because you made the model rush the answer. But if you just add think step by step about schema relationships before giving the SQL, it creates this amazing self-correction loop that significantly boosts your code accuracy.
Section 4, Technique 3, Structured Output. Because let's be real, in a live incident response scenario, nobody has the time to sit there and read paragraphs of conversational fluff. You fix that by dictating the exact output schema. When you specifically tell Claude, respond only in JSON with keys root cause, affected service, next steps. The model uses something called constrained decoding. That guarantees valid data formats, completely stripping out the chatty conversational stuff.
The result? You get a perfectly clean JSON or table output that looks like it came straight out of a code editor. It is instantly actionable. You can literally copy and paste these outputs directly into your ticketing system or your automation scripts simply because the structure is entirely predictable.
Which brings us to Section 5, Technique 4, Contextual Injection. This one is absolutely crucial for ensuring Claude actually knows what's happening in your specific environment, rather than just guessing based on its training data.
Contextual injection uses structural markers, specifically XML tags like context and task, to separate your raw data from your instructions. And here's why this is so insanely powerful. Anthropic actually uses XML tags in their own internal system prompts. So Claude recognizes them natively, allowing it to flawlessly parse multi-part instructions without mixing up your prompt with the raw log data.
Now, a quick warning. When injecting context, do not just paste a 10,000-line log dump. That just clogs up the context window. Instead, you want to carefully curate the items inside your XML tags. We're talking century error stack traces, maybe 5 to 10 lines of relevant logs, recent config changes, and explicit constraints. Trust me, 5 curated lines of context beats 5 paragraphs of clever prompt engineering any day of the week. Okay, Section 6, Scenario, Payment Timeout Incident. Imagine this. It's 3 a.m., the pager's going off, and users are suddenly reporting payment timeouts. Let's look at how all this builds into a real-world, high-stakes workflow. Here is the exact incident response workflow that combines all 4 of our techniques. First, we grab the century error. Second, we inject a short, relevant log snippet using XML. Third, we request a step-by-step diagnosis. And finally, we generate a Loki query for verification.
And here is the mega prompt that does the whole shebang. Just look at how we systematically stack these techniques. Saying, you are a senior SRE, assigns the role. Those bracketed logs, that's contextual injection. Think step by step to diagnose, triggers chain of thought. And respond only in JSON guarantees our structured output.
When you hit enter on this, you don't get a chatty, generic response. You get perfectly formatted output. It hands you a highly specific hypothesis, like, say, the DB pool size limit being reached. And it gives you the exact Loki query you need to verify it right then and there. There's no guessing, it's just fast, surgical troubleshooting.
By combining these 4 techniques, you stop hoping for good answers and you start actually engineering them. So my final question to you is this. How much faster could your team resolve the next critical outage if you stopped treating AI like a search engine and started briefing it like a senior SRE? Build a prompt library with these techniques, and I guarantee you'll watch your instant response times absolutely transform.